Hello class, today we are looking at using the quadratic formula. So I know some of you have been talking about this in class and wondering when we would learn it. Methods to solve quadratic equations. So first of all, let's just kind of review all the different ways we have to solve quadratic equations. So again, quadratic equations have an x squared term. So the first one we learned was to rewrite in factored form equals 0 and then use zero product property. So let's go ahead and write factored form here. Another way is to complete the square. But if we cannot easily use either of these methods, we can use the quadratic formula. So we're going to go ahead and use this below. I've got the formula. It's all typed out here for you, so you don't have to look back at your notes. Oops, sorry about that. But we're going to practice using that on a bunch of problems right now. So remember, quadratic formula works for ax squared plus bx plus c equals 0. So we find our coefficients because a is our coefficient of x squared, b is our linear coefficient, c is our constant, and it needs to be equal to 0. So our first equation is in the right format. So if I go through and identify my constants, my a would be 3, b is -1, and c is -2. So my first step is just to substitute into the equation. So I have x equals, it says negative b. B is already a -1, so I'm going to have negative of -1. Then we've got that plus or minus square root of b squared. So -1, that whole quantity squared, minus 4 times a times c. So 4 times 3 times -2. The square root goes over all of that stuff, and this is all over 2a, which is 2 times 3. So let's think about our order of operations. Order of operations, I would want to start inside that square root because my square root is like a grouping symbol. So I'm going to go ahead and do the -1 squared and multiply the 4 times 3 times -2. I know the subtraction part in here, that part has to come last. So I'm going to kind of do all of this, the -1 squared, and I'm going to do this right here. And I'm even going to do this one in the bottom, and I'm going to simplify this. So remember, the adding and subtracting part has to come last. So negative of -1 is a +1, plus or minus. -1 squared is going to make it a +1 minus 4 times 3 times -2. Well, 4 times 3 is 12, times -2 is a -24. And this is all over 6. Now remember, because we have a minus negative, this is going to be plus. And so we end up with x equals 1 plus or minus square root of 25 divided by 6. So remember, 25 is 5 squared. So if I rewrite square root of 25 as square root of 5 squared, we can easily see it's just 5. So x equals 1 plus or minus 5 divided by 6. Okay, so at this point we need to write our two different equations because of that plus or minus. We have to split it up. So it's either x equals 1 plus 5 divided by 6 or x equals 1 minus 5 divided by 6. So the first one would be 6 over 6 or 1. The second one would be, let's see, 1 minus 5 is -4/6 or -2/3. So there's our answers for the first one. All right, looking at the second one, I can already see that I don't have everything, like I don't have this right format. I need my quadratic term, linear term, constant equal to 0. So I want to move everything over to the left-hand side. I like my x squared to be positive. So I'm going to subtract 5x and add 3 on both sides. And what that does is leave 0 on the right-hand side. My left side is x squared minus 5x plus 3. So let's go through and identify our a, b, and c again. So because I have x squared, there's no number in front. Remember, there's an imaginary 1 there. So a equals 1. My linear term, negative 5xb, is going to be a negative 5, and c is going to be 3. So let's go ahead and substitute into the quadratic formula. So x equals negative b, but b is already a negative 5, so negative of negative 5 plus or minus square root of b squared, so negative 5 squared, minus 4 times a is 1, c is 3, all over 2a, 2 times 1. So remember, we're going to do like all of those spots again, right? So negative of negative 5 is a positive 5. And then I'm going to go ahead and take my square. So negative 5 times negative 5 is 25. Minus 4 times 1 times 3 is 12. All over 2. And then I want to subtract. 25 minus 12 is the square root of 13. And I can totally leave my answer this way. The book is probably going to take one step further and say this is 5 halves plus or minus square root of 13 halves. So you could certainly break it apart. If you were feeling really fancy, you could even write like x equals 5 halves plus root 3 over 2, or sorry, square root of 13 over 2, or x equals 5 halves minus root 13 over 2. I don't think it's necessary to do all of that. We are really happy if you can get your answer to right here and then stop. All right, let's look at the next one. Next one, I definitely need to move my 6x over to get started because it needs to be equal to 0. So now I have 2x squared minus 6x plus 15 equals 0. So let's go ahead and identify our coefficients again. A is going to be 2, B is negative 6, and C is 15. B has been negative every single time. So quadratic formula, x equals negative b. So negative of negative 6 plus or minus square root b squared, so quantity negative 6 squared, minus 4 times a times c, so 4 times 2 times 15. Going to make my square root go over all of that. 2 times 2. So let's go through and do all those little pieces again. So I have a positive 6 now. 6 squared is 36. 4 times 2 times 15. Let's see. Well, 2 times 15 is 30. And 4 times 30 is 120. And this is all over 4. So this is getting a little bit weird, and I don't know if you can see that yet or not. But when I subtract 36 minus 120, I have a negative 84. So we know that we cannot take square roots of negatives. So this one is going to have no real solution. Right, for the last one, everything is already in the right format. A is 1, B is a negative 8, C is 16. So x equals negative b, well that'll be a negative of negative 8 plus or minus square root of negative 8 squared minus 4 times a times c, so 4 times 1 times 16. There's a really great rhyme for a quadratic formula to the tune of Pop Goes the Weasel. And I can never sing it, but it's easy to look up online. It might help you remember. This is a formula you'll have to have memorized. So negative of negative 8 is a positive 8, plus or minus. Let's see, the quantity negative 8 squared. Remember, that's negative times negative. That's a positive 64. 4 times 1 times 16, though, is also 64. So this is going to get a little bit weird. 2 times 1 is just 2. So we end up with 8 plus or minus the square root of 0 over 2. So the square root of 0 is 0. So remember that. Square root of 1 is 1. 1 times 1 is 1. Square root of 0 is 0 because 0 times 0 equals 0. And the square root of something that is negative means that we don't have any real solutions. These are some things that we kind of struggled with yesterday. So square root of 0 is just 0, so 8 plus or minus 0 over 2. Well, it doesn't matter if I add 0 or subtract 0. It's just 0. So this is really just 8 divided by 2, which means x is going to be equal to 4. So an interesting thing to point out here is that anytime we actually have a number inside the square root, like on this one right here, or on the first one that I can take the square root of, anytime that b squared minus 4ac was a perfect square, and I'm considering 0 to be a perfect square, I can take the square root, then really we could have solved this by factoring and using zero product property. So only on a problem like 2 or 4, this one where I had a square root of a weird number, that I can't factor. And on number 3, when I had no real solution, is also not factorable. So it really was possible to solve half of these problems using a different method. The quadratic formula is a lot of work. So really, we want it to be our last resort. We want to try everything else before we do quadratic formula. We're going to look at 2 more problems, and we're going to try solving them with the most appropriate method, which means we're really going to think about what we do before we go through and solve. So for this first one, 3x squared equals 5x. First, I would want to subtract 5x on both sides. So 3x squared minus 5x is equal to 0. And then I am going to go ahead and factor x out of both of those. I only have 2 terms. So if there's 2 terms, I won't say 100% of the time because maybe there's some crazy thing I've not thought about. But you don't have to use a quadratic formula. You're either going to be able to like take a square root or you're going to be able to factor. So both of these terms have x. I'm going to factor out an x from both. So I write the x in front. If I have 3x squared, but I'm factoring out one factor of x, I'm left with 3x minus, if I have 5x and I'm factoring out an x, I'm just left with 5. And if you're not sure, if you don't believe me, you could go back and you could re-multiply this, right? So x times 3x is a 3x squared minus x times 5 is a 5x. So that does work. So let's go ahead and erase this like multiplying it back part. All right, so now what I want to do, that I have it factored, is I want to do zero product property. So either x is equal to 0 or 3x minus 5 is equal to 0. And the second one, I do have to show my solving steps. I'm going to add 5 on both sides, and then I'm going to divide both sides by 3. So on the second one, I want to think about factoring here. So let's see. So for 9, I have 1 times 9 or 3 times 3. And it looks like my middle term is negative. That means my bigger number would be negative. But my problem is 1 plus negative 9 is not equal to negative 6. And 3 plus negative 3 is not equal to negative 6. That means it is not factorable. So I could do my entire quadratic formula, but the other thing that I notice is I have a 1x squared and 6 is even. So I could use completing the square on this one. So you could do quadratic formula, but it's going to be a lot longer. So I'm going to go ahead and choose to complete the square. So I'm going to first move my constant term to the other side. So I have x squared minus 6x equals 9. And then I have to figure out that number that completes the square. So let's take half of 6 and then square it. So half of 6 is 3. 3 squared is 9. So I'm going to add 9 on both sides. So now I have x squared minus 6x plus 9 equals 18. And then I'm going to factor. So on the left-hand side, this is going to factor to the quantity x minus 3 squared. On the right-hand side, I just have 18. And then because it's squared, I do want to take a square root on both sides. So this is like what we learned about yesterday, where we have irrational numbers. So 18 is not a perfect square. I'm going to just leave it as a square root of 18. I could write a decimal. I could go ahead and I could figure that out on my calculator. It's going to be a little bit more than 4, maybe like 4.3 or something. But we don't really want to work with decimals. So we're going to leave it as a square root of 18 because it's irrational. On the other side, my square and root cancel, and I have an absolute value of x minus 3. So this means I could write x minus 3 is equal to positive or negative square root of 18. So we still have to remember our positive and negative, and I have not taken a square root on the right-hand side, so it has to stay with that square root symbol. My last step is adding 3 on both sides, and so I have x equals 3 plus or minus square root of 18. So like I said, we could also have solved this with the quadratic formula, but that is a lot more steps. There's a lot more variables to substitute. There's a lot more things going on. And this is a method that we're always really good at. We're already really good at. But there are different ways to solve quadratic equations, and that's something we're going to have to think a lot about in this chapter. So main ideas today, we are gaining a new way to solve the quadratic formula, right? And that's what we're going to be practiced in your activity. We're going to continue practicing this over the next couple days. But it might not always be the best way. It might be the most difficult way. You will have to have that quadratic formula memorized, so don't forget about that. If you have any questions, as always, please make sure you ask.